Assalamu alaikum and good evening, my dear viewers. Welcome once again to another episode of Techno right here on IBN. I am happy and honored to introduce myself for the very first time as Dr. Shahanshah Ali Qasim. Yes, I have recently returned from San Francisco, where I went to receive my doctorate in business and technology. And it has been a long journey, I must say, but the reason why I'm saying this, it is to encourage those of you out there who have aspirations sometime, in life. We work towards our goals, and inshallah, God willing, after many obstacles and many hurdles, once we have a vision and we work towards it, we will indeed achieve our goal. Let's ask the studio to pull up that one little clip indicating that I did. There we go. So this was on the day of my convocation when I went to receive my honorary doctorate. Now, coming back to me. Right, so one of the places that I went to, of course, is San Francisco, California. I was privileged to be there for a couple of days, and I was happy to visit Silicon Valley. And what that means is that Silicon Valley, as most of you know, is the largest tech, if you want to call it tech mecca of the world. So most of the startup companies in technology would have started there, including Hewlett-Packard, Apple, and so many others. I've had the privilege to visit some of them, and having been there, this is me actually at the outskirts of Intel, and I've been able to bring in some of the clips that I was able to get straight from the company, and this is me at Google. I did visit Meta, which is Facebook, as well as some other companies, but because of time and limitations of being able to interact with some of the seniors there, it was difficult to actually meet everyone in that short space of time. So our program tonight, now that I've been to return from Silicon Valley, I'm going to show you some clips based on what we would have gotten from Intel, direct from the source. And as we go along, we will talk a little bit about what we expect in terms of the future and where we are heading in terms of technology. So my first clip that I'm going to show you is how processors were made, and this came from Intel. And we go to that one. There we go.
Okay, quick question. Why do Intel processors sound like superhero names? You've got Celeron, Pentium, i3, i5, i7, i9. It's like the Avengers, but for your laptop. The only problem? You don't know who's Iron Man and who's just the guy making coffee in the background. All right, let's go one by one through Intel's processors, from the baby of the family all the way up to the monster. First up, Celeron. Now imagine you're trying to get around town and all you have is a squeaky old bicycle. That's Celeron. It gets you from point A to point B, but don't expect it to win any races. It's cheap, slow, and really only meant for the basics, like checking emails, writing essays, or maybe watching YouTube, as long as you don't open 20 tabs at once. These chips usually end up in budget laptops and school Chromebooks, perfect for students just typing papers, or if your grandma wants to check Facebook. But if you try gaming on it, well, that's like trying to run a marathon in flip-flops. You'll regret it halfway through. Next is Pentium, which is kind of like an electric scooter. It's still not a car, but at least it's got a motor. Pentium gives you a little more speed and a smoother ride compared to Celeron. You can stream Netflix, join Zoom calls, browse the web, even multitask a bit without it crying in pain. It's a good option for people who want something cheap but don't want to feel like their laptop is stuck in 2004. Of course, it's not built for heavy gaming or editing. Asking Pentium to do that is like asking the kid who always got picked last in dodgeball to suddenly dunk like LeBron James. But for students, office workers, or casual users, it does the job just fine. Now let's move into the Intel Core family, starting with i3. Pentium was the scooter. i3 is your first car. Think Toyota Corolla. Nothing flashy, but reliable, affordable, and it won't fall apart on the highway. With 2 to 4 cores, depending on the generation, i3 gives you enough power for schoolwork, Netflix, multitasking, and yes, even some gaming. Minecraft, Fortnite, League of Legends, no problem. But try running Cyberpunk 2077 on this thing and you'll learn what lag truly feels like. So if you're a student or casual gamer, gamer who just wants something simple but not frustratingly slow, i3 is a great entry point. Like buying fast food, it's not gourmet, but it fills you up without draining your wallet. All right, here's where things start getting good. The i5. The i5 is the Honda Civic of processors. Affordable, reliable, and surprisingly powerful when you need it. This is the sweet spot for most people. With 4 to 10 cores, depending on the generation, i5 strikes the perfect balance between price and performance. You can game, edit videos, stream, and multitask without problems. It's the processor for people who want to do everything without spending a fortune. If you're building a gaming PC on a budget, this is usually the go-to. You get solid performance without going overboard. Honestly, an i5 is like pizza. Literally everyone loves it, whether you're a gamer, a student, or just someone who wants their PC to actually keep up with them. Next up, i7. Now we're in sports car territory. The i7 is fast, flashy, and built for more than just the daily commute. With more cores, higher clock speeds, and hyper-threading, it's the processor that laughs at multitasking. Gaming, streaming, editing 4K videos, you can do all of it at the same time and still have power left over. It's a fantastic option for professionals, creators, or gamers who want to max out their settings. But if all you're doing is checking emails, then buying an i7 is basically like bringing a bazooka to a water balloon fight. You'll win, but come on, man, was that really necessary? And finally, the big boss, the i9. If processors were cars, this is Formula One. Insanely fast, insanely powerful, and yeah, insanely expensive. The i9 is Intel's top-of-the-line beast, packing the most cores and the highest speeds. It's built for people doing heavy-duty tasks like editing 8K video, running massive 3D projects, scientific simulations, or hardcore gaming at ultra settings. For professionals and enthusiasts, this thing is a dream, but for most people, way too much. Using an i9 just to scroll Instagram is like buying a Ferrari just to drive to the grocery store. Yeah, your milk gets home faster, but your wallet is crying. So there you go, from the squeaky little Celeron bike to the Formula One i9 monster. Each processor has its place, and the right one depends on what you actually need. Students and casual users stick with Celeron, Pentium, or maybe i3. Gamers and creators, you'll be happy with i5 or i7. And if you're a professional who needs insane power or just someone who loves flexing, then i9 is your guy. Don't forget to subscribe.
Right. So what you would have seen there is a little explanation in terms of what some of the desktop Intel processors are about. We went from low end to high end. And of course, if you have a machine, you have a computer, you have a laptop, you're thinking about doing an upgrade, these are some of the processors under the Intel brand. Of course, there is AMD, which is another chipset as well. I unfortunately was not able to visit that plant. But one of the things is that, we talk about processors. And for the average person, when we hear processors, we think, okay, what is a processor? Is it an integrated chip? Is it an IC? Is it what we call a little computer chip? Yes, it is. And a question might come to your mind, so how exactly is it made? All that power, all that brain, all that thinking, all that, what is it? In that little piece of fine, minute circuit board. Well, our next clip I'm going to show you, it is entitled From Sand to Silicon, and that is, of course, how the actual microchip was made. Let's take a look.
The world is producing data at an unprecedented rate, faster than our ability to analyze and understand it. To move, store, and compute all of this data requires incredible processing power. From the blazing speeds of our devices to blazing trails within AI, Intel builds chips that are at the heart of nearly everything. Within every Intel chip manufacturing facility across the globe, innovators are pushing the limits of science and literally rearranging atoms to create groundbreaking technology. This strong silicon foundation is what gives each Intel chip limitless potential. At the heart of all modern electronics, the transistor is a tiny switch, 10,000 times smaller than a human hair, that controls the flow of electrons through a circuit. To build a processor, billions of transistors are packed into an area no larger than a fingernail. It's one of mankind's most complex feats and a remarkable achievement that Intel has essentially doubled transistor density in every new generation of processors. The process begins when silicon-rich sand is melted and cooled, forming a solid, which is then sliced into wafers. Once inside an Intel fab, the raw wafers begin their long journey through an incredibly complex process. They're loaded into front-opening unified pods, or FOUPs, which travel hundreds of miles along Intel's automated superhighway, going from tool to tool, as processors are painstakingly built up on each wafer. The wafer first goes through a series of important steps, such as photolithography, ion implantation, and etching, that prepare it for the critical transistor formation process. Intel was the first to manufacture three-dimensional transistors called FinFETs. FinFET construction requires first building a channel in the form of a fin. Intel has devised several innovations to overcome fundamental barriers to continued transistor scaling. One such innovation is a breakthrough fabrication method called gate last. It involves building, then removing a temporary gate in order to precisely place the dielectric material and metal gate. This allows for the gate to wrap around the fin and control the flow of electrons through the channel. Another invention moves the transistor contact directly over the active gate. To accomplish this, the gate material is recessed and then filled with insulating dielectric material to prevent the creation of a short circuit. Next, the dielectric near the gate is etched, filled with metal, recessed, and capped to allow a novel self-aligning process that enables the high-density contact geometries. Now, the dielectrics are etched selectively to expose only the desired part to connect to the first metal lines. This is done through an innovative via etch and deposition scheme, allowing contact over active gate to happen. Finally, dozens of layers of metal interconnect lines are added to complete the circuit. After more than 1,000 of these complex steps, the wafers are finally prepared for singulation and packaging. Innovative processor packaging has become a critical feature of advanced computing architecture. 2D and 3D packaging technologies are enabling new device form factors and additional boosts in performance and energy efficiency. Testing of the final product ensures that every chip exceeds our performance and quality standards. In addition to adding more performance and features with each new processor generation, Intel's integrated design and manufacturing capabilities have enabled humanity to innovate game-changing technologies that impact nearly every facet of modern life. Intel keeps powering the world. At the same time, we're powered by you, the makers, the dreamers, the doers, the people who share in our history of making the world smarter, faster, and more connected.
Okay, great. So now that we have seen exactly how the chips are made, you take in raw silicon. So that silicon we'll be talking about, it is actually silica, which is sand, and it's refined, it's melted, and it's actually formed as a big mold. From that, it's sliced, and then the etching actually begins. Now, the other question will be, we have so many computers in the world. We have not hundreds or even thousands, but in some cases, millions of computers. We're talking about laptops, desktops. Typically, most homes in the US have at least 2 or 3 computers. Some of you guys out there might have 2 or 3 computers as well. We talk about computers in schools. We talk about desktops and laptops. We talk about computers at work, in the offices. We talk about computers at home. And all those multiple machines have some type of circuit board, some type of microchip. The question now would be, how do you scale that production? How so many microchips are manufactured to actually upscale and be able to be introduced into the market to meet the demands of so many? Our next video, we're going to show you how are billions of microchips made, and this is from right in the factories in San Francisco. Let's take a look.
It is possibly the most revolutionary invention of the last 50 years. Since they were invented, microchips have evolved and have become electronic superbrains, capable of performing over 1 billion calculations per second. Creating these extraordinary miniature electronic brains is one of the most complex tasks ever done. But how are silicon microprocessors made? Discover the amazing process of producing billions of microchips in a semiconductor factory. Modern microprocessors contain billions of transistors on a single chip, and most electronic devices today use them. In 1958, the inventor of integrated circuits, Jack Kilby, managed to put a single transistor in his design. The latest generation uses nearly 1 billion transistors, and according to Moore's law, this number doubles every 2 years. This company produces 70 billion microchips a year, which are used in many devices from washing machines to smart cars, and each one of them is a miracle of miniature manufacturing. A processor works thanks to the circuits of millions of individual components called transistors. The more transistors we put on a chip, the faster and more powerful it will be. In this amazing and futuristic-looking factory, silicon sheets are produced, which are the foundation of all modern microchips. The substrates for microchips are made from quartz sand and are called silicon wafers. Silicon possesses distinctive characteristics due to its classification as a semiconductor. This means that depending on how it's treated, silicon can either conduct or block electric currents. It is this property that makes it perfect as a support for the millions of tiny transistors needed to make a modern microprocessor. The problem is that, since these transistors are so small, the silicon base on which they rest has to be completely perfect. It took decades to perfect the manufacturing process of silicon with a perfect monocrystalline structure. To manufacture these wafers, a huge single crystal is extracted from the melted mass of purified silicon. It starts with polycrystalline silicon, which is heated to about 1420 degrees Celsius inside a special sealed oven. This oven has been purged with argon gas to eliminate air. The melted silicon we get is spun in a crucible. The result is a silicon crystal that weighs about 200 kilograms and has a diameter of about 200 millimeters. The crystal is so strong that it supports its entire weight with a single thread that is 3 millimeters thick. So after several tests with chemicals and X-rays, it is put into a silicon wafer cutter. This 10-ton cable saw uses a network of very thin cables that move very quickly to produce silicon wafers. They are only 2/3 of a millimeter thick with a purity of 99.9%. But once cut, microscopic marks have been left on the surface, so they must be polished through a process called lapping. But even after going through this modern polisher, the sheets are not smooth enough, so they have to be polished again through a chemical process. The result is silicon wafers with a surface roughness of less than 0.1 nanometers. Already completely polished, they are now finally ready to start with the circuit design. Using computer-aided design software, engineers create the detailed design of the circuit. Once the circuit design is completed, a thorough verification is carried out to ensure it meets the required specifications. 25 wafers are packed in a completely sealed container and sent on a journey that will take them through hundreds of manufacturing steps. Placing millions of transistors on these small sheets is the job of chip manufacturers. The problem for this factory is that these transistors are about 200 times smaller than a red blood cell, and making something so small is a huge production challenge. Fortunately, there's a machine that does it. It's a photolithography machine, and it can print billions of transistors on silicon wafers every hour. Before entering the machine, each plate is covered with a liquid that reacts to light. This is what is called the photoresist, and it reacts to light like the film of a camera in a dark room. The photoresist is a chemical agent, very sensitive to light. That's why this room has a yellow light. Otherwise, normal daylight would spoil the plate. Photolithography techniques project circuit structures onto semiconductor wafers, similar to the way images are transferred in slide projection. The machine emits a laser that crosses the designed plane of a transistor and engraves it on the silicon plates. Just like in a photo, this leaves an image of the transistor on the plate. When the chemical is removed, the design remains like a photographic image. However, to place all components on the sheet, it must be done layer by layer. To complete the process, the sheets undergo the same cycle multiple times, typically repeating between 15 and 40 cycles. Transistors are built level by level, like mini skyscrapers, which results in hundreds of microchips, each of which has more than 1 billion transistors. The challenge is to double the number of transistors on a chip every 2 years to meet the demand for increasingly powerful devices and computers. The biggest challenge for engineers is finding new ways to improve the laser beam that engraves the shape of each transistor. They discovered that by passing the laser beam through a layer of water, similar to sunlight passing through a magnifying glass, they can significantly increase the beam's intensity. This innovative approach allows for the reduction of transistor dimensions to about 5 times smaller than the smallest bacteria. However, building machines that rely on this level of precision is a nightmare. It takes 3 months to assemble and test the 800 circuits, 1,300 cables, and 400 boards that make up these water-enhanced machines for making transistors. The finished product will help produce smaller and more powerful microchips. Working at this microscopic scale poses a significant challenge for microchip manufacturers. When a transistor has a width of only 1,000th of a millimeter, the smallest particle of dust can cause a short circuit. A single particle landing in an area can destroy a chip. So before workers get to work in the factory, they must put on the protective suit. The manufacturing process takes place in a clean room of almost 18,000 square meters. Thanks to 12,000 tons of air conditioning equipment, the air in this room is a lot cleaner than that in an operating room. Every employee must take an air shower every time they enter a clean room to remove invisible particles of dirt and dust. The entire air inside the factory is refreshed every 2 minutes, making it 10,000 times cleaner than outside air. Copper dominates the next step of the process. The thinnest interconnecting wires join billions of separate transistors to form the integrated circuits. Before that happens, cleaning is essential for wafers, as particles lurk at every stage of the manufacturing process. Before pouring copper into the trenches for interconnections, a barrier layer is applied to help prevent short circuits and ensure reliability. Then the trenches are filled with copper. The leftover copper is ground down to the edges of the trenches, isolating each interconnection from the others. In 2 months, the wafer is ready. While individual conductors within the integrated circuits are typically measured in micrometers or millimeters, the cumulative length of all conductive traces can extend over several kilometers. These intricate circuits connect 100 billion transistors on numerous levels, all within a space no larger than a fingernail. The finished silicon sheets carry up to 1,000 different microchips and over 4 trillion circuit components. Now, they just need to be cut and trimmed, and the long journey from being sand to a circuit board will be complete. The final step in microprocessor production is chip encapsulation. To prepare for this step, tin and silver granules are applied to the wafer. These will bond the chip to the frame. What was once a pile of worthless sand can now be sold for hundreds of dollars per gram, showcasing the remarkable transformation in semiconductor manufacturing. If you want to know how AI robots are made, watch the video on your screen. And please like.
Right. So what you just saw there, okay, it is exactly how those chips are made and how they actually cram. So just to give an idea, a physical wafer, not a wafer that you eat, a physical wafer, silicon wafer, is approximately this size. That's the size of it. And on that circuit, on that surface of that wafer, you have a few thousand chips that actually form into that wafer. And after the chip is manufactured, then it's cut and individually removed and, as you saw, encapsulated. Now, it is amazing to think how we have this knowledge, we could actually take that information and cram it down into a small little space, maybe the size of our fingernails. And that is amazing. But the reality is that whole concept of how that is manufactured is generally done by robots. Because of repetition and accuracy, the humans are there, but the humans are the ones who are actually running the equipment, while the actual equipment, the robotic arms and so on, are what is used to move around the items. And you know, this is a clean room. So I've been into one of those clean rooms, and the entire floor is made of a metal mesh where you actually have breeze or air pulling and filtering the air one time, so there's a constant flow. It's not a solid ground you're walking on. It's a mesh of aluminum or some type of metal framing, and air is being pulled from underneath and air is being pushed from on top. So the air is constantly being filtered to ensure that even the water vapors that we exhale is not even absorbed or even allowed to settle on any of the surfaces of the circuit. We take a break now, and when we come back, we will continue our topic, talking about Intel chips, how it's made, and I'll tell you a little bit about what I saw when I was in San Francisco. Stay tuned.
At Extra Foods, we care for you. That's why we always have the widest variety, the best prices, spacious aisles of total convenience, plus clean, safe surroundings. Let us care for you. Extra Foods, always extra for less.
The Baraka December Expo is back. Come on down to the Baraka grounds in Central Trinidad from Friday the 19th of December to Wednesday the 24th of December. Get ready to shop and explore a wide range of wonderful vendors offering unique gift items at affordable prices with the widest variety of choices. So remember the dates, Friday the 19th of December to Wednesday the 24th of December. 6 days of fantastic shopping at the Baraka grounds in Central Trinidad. It's the Baraka grounds December Expo. Don't miss it.
Never too early, never too late to recharge and hydrate. Get your daily dose the right way. Grab an Oasis, now why wait? Never too early, never too late to recharge and hydrate. Get your daily dose the right way. Grab an Oasis, now why wait? The greatest, the safest Oasis for sure. Oasis, it's purer than pure.
Welcome back once again to Techno on IBN. I am your host, Dr. Shahanshah Ali Qasim, and of course, if you're looking at this program for the first time, this program will be aired on Thursday evenings from 8 to 9 p.m. right here on IBN. It's a live broadcast, and sometimes we will have the lines open up so you can, participate in the program. And sometimes if I have a guest, depending on how the program is structured, we might be able to have some giveaways and so on. So definitely mark it on your calendar, Thursday evenings, 8 o'clock, 8 to 9 p.m., IBN, Techno Live. Just remember that. So right before we went on the break, I was talking a little bit about my little journey that I took recently. The last couple of weeks, I was out of the country. And I did go abroad to receive my doctorate in business and technology. And part of that, that was done in San Francisco. I got the degree from the university, the Orange County University in California. And the nice thing about it is that I was there for a few days, so I was able to tour some of the tech companies in Silicon Valley. And of course, having been able to tour those companies firsthand, it means now that I'm here to bring back some kind of footage or some kind of report based on what I would have seen. And I did visit some of the bigger companies. As I said, I visited Intel, I visited Apple, I visited Google, and I was able to go to Meta and a few other companies, but because of time constraints, I was not able to interact with anyone to do an interview, as the case may be. Hopefully, maybe next time that I go, I'll probably try to book those appointments earlier. Right before we went on a break, I was showing you some footage that I brought back from Intel. Of course, for those of you who don't know, Intel is one of the larger manufacturing companies of chips or microprocessors. Those are the actual brain that actually go into your computers or your PCs or your laptops or your tablets. And that is the company who actually manufactures those chips. So other than in computers, it has those type of chips in things like smart screens, smartphones, even smart cars. Well, we will talk about smart cars at another point in time. How does those chips or how does those processors interact into the everyday computer? Well, our next clip that I'm going to show you, how does computer hardware work, that will show you exactly the breakdown from a graphical point of view, how it's disassembled, and how the actual components are put together to work one together with the other to actually function as a computer as we know it. Let's take a look. How does computer hardware work?
Throughout this video, we're going to do a desktop computer dissection using 3D animation, kind of like a dissection lab in biology class, but instead, we'll journey through the inside of this computer and disassemble every piece of hardware. We'll then use a microscope and zoom in to give you a nanoscopic view of the transistors and other structures inside. To make this video, we disassembled all the hardware inside a typical desktop computer. We desoldered and removed the components from each of the printed circuit boards and took thousands of pictures. Then, using these pictures, we meticulously 3D modeled every single component from the computer case down to the tiniest resistor. As a result, here's all the hardware that we'll explore throughout this video. It kind of looks like a crime scene where someone viciously destroyed a computer and arranged all the components. But anyways, let's dive right in. We'll begin this journey with the Central Processing Unit, or CPU, which is the brain of the computer. On top, we have the cover, called an integrated heat spreader, and inside is a smaller metal package that holds the integrated circuit, which is technically called a die. This die is mounted on a printed circuit board that distributes the 1200 connection points to landing pads that interface with the landing grid array on the motherboard. The integrated circuit inside has a few different sections, but perhaps the most recognizable are the 10 cores where programs and instructions are run. Each core is quite complicated, so here's a diagram laying out the different functional sections. There are dozens of rather complicated elements in this diagram, and you can look forward to a series of videos we're currently planning which will explore computer architecture and how each of these sections work. Let's zoom into a nanoscopic view of the integrated circuit so we can see individual transistors. These transistors are incredibly small, only a few nanometers wide, and in this die there are approximately 8 to 10 billion. On top of the transistors are multiple layers of metal wires, with vias rising vertically between the layers. Together, these transistors and wires create a multi-layer labyrinth or highway, resulting in a computer that can execute billions of operations every second. Let's now zoom out and look at other sections of the CPU. To the side of each core is the shared L3 memory cache and ring interconnect. On the far right is an integrated graphics processor which functions as a less powerful GPU. In the top left is the memory controller, which sends data to and from the DRAM. And finally, on the far left is the system agent and platform I/O, which communicates with the chipset on the motherboard and manages the flow of data between many of the other components in your PC. So with that in mind, let's move on and look at the motherboard. This motherboard is a massive printed circuit board with thousands of wires running inside and a variety of microchips, components, sockets, ports, slots, headers, and connectors soldered to it. Perhaps the single most important and expensive component, aside from the bare PCB, is the chipset, which is this integrated circuit found underneath a heatsink down here and is connected directly to the system agent section in the CPU. Here's a diagram illustrating how the CPU and chipset are connected to everything else. As seen here, the CPU connects directly to the DRAM, one or two displays, the GPU, and perhaps a few SSDs plugged into the M2 slots. The chipset manages most everything else: data flowing through the Ethernet or Wi-Fi, data going to and from solid-state drives and hard drives plugged into the SATA ports, some of the PCIe slots, your keyboard and mouse, USB devices, and the audio sent to the speakers or from the microphone. Just a quick note. Computer hardware has evolved immensely over the past 65 years and continues to evolve. So the details we show should be thought of as a current-day example PC and not as how all computers work. Let's move on and skip over the many different sockets and connectors throughout the motherboard and focus on the voltage regulator module, or VRM, found near the CPU. These components are used to drop the voltage coming from the power supply down to the 1.3 volts used by the CPU. As a result of all the power flowing through these components and their 80 to 90% efficiency, heat sinks need to be placed on top. While we're on the topic of power, this CPU consumes power equivalent to approximately 16 LED bulbs, thus generating a considerable amount of heat, which is taken away by the CPU cooler. This particular cooler uses a pump to circulate liquid through these tubes and into the radiator's channels, which transfers heat to the radiator fins. The fans then help transfer the heat to the air, and the cooled liquid returns to the pump via the return loop. The pump is a brushless DC motor, constructed from a PCB, a control chip, and a stator on the dry side, a barrier in the middle, and then the permanent magnet rotor and impeller on the liquid side. There's no mechanical connection between the rotor and stator, thereby preventing any leaks of the cooling liquid. Let's move on to the power supply, which distributes power throughout the computer. In here, the main transformer reduces the voltage and bridges the isolation boundary between the primary side high voltage and the secondary side lower voltages used throughout your computer. Here's the control PCB that ensures a stable output voltage and sends adjustment signals to the switching power transistor on the primary side using opto-isolators. There are dozens of other components used to filter the input voltage and generate various output voltages, which are then sent to all the different hardware in your computer. For example, an SSD consumes just a few watts, and the connector uses these voltages, whereas your GPU can consume hundreds of watts using these connectors and these voltages. Next, we'll explore the GPU, but before that, let's take a step back and consider the technology we've covered thus far. Alone, each of these components doesn't do much at all, but when united, they combine to form a powerful system. Similarly, this video is a multidisciplinary combination of engineering, technology, art, and animation inspired by the Magic School Bus. We can't emphasize enough how important it is to be a multidisciplinary student. And to help you do that, the sponsor of this video is Brilliant.org. Brilliant is a multidisciplinary online education platform which teaches a ton of different topics in hands-on interactive ways. Here are 2 courses from different disciplines that you might think were entirely unrelated. However, when combined, they provide the foundational basis for a cutting-edge field of science and engineering.
Okay, so what we would have seen now is how that computer worked. And just for those of you who are looking at this program and you're hearing those acronyms, CPU, GPU, and you're getting a bit confused, each one of those is just an acronym for GPU, graphical processor unit, CPU, your central processing unit, or the brain of the computer. And the GPU is normally what is referred to as the graphics brain, or the main part of the computer that processes chunks of data for graphical processing. And when we get into the topic of AI, artificial intelligence, which is something that we're going to be talking about as we go along, you will understand that the better the GPU, or the more complex the GPU, the faster the data is processed for the output, and that is required for artificial intelligence to take place. Now, speaking about artificial intelligence, one of the things that I saw when I was in San Francisco, and of course, as you know, I'll refer back to Silicon Valley, and again, my personal experience. Silicon Valley is one of the homes, or that whole area of San Francisco is one of the homes of a brand that is known as Tesla. Now, most of you would have heard of Tesla, some of you would have heard it in the news, and so on. But Tesla generally makes electric cars. So one of the programs that we'll be doing very soon, we'll be talking about EVs, and we'll be diving into the differences of electric vehicle as opposed to a traditional vehicle. What are some of the pros, some of the cons, moving forward, what to look for, what we would have heard in the news, things like that. But today is not that program. What I've found is that while driving on the highway, while walking on the road, even when I was staying at the hotel, in the hotel there's a whole section of the car park with multiple charging stations dedicated for EVs, or electric vehicles. While I was on the road, maybe out of every 10 vehicles that I passed, now when I say 10 vehicles, I'm not talking about trucks, we're talking about cars, SUVs. Out of every 10 vehicles that I passed, 5 of them in San Francisco was a Tesla. They had different models. And then out of the next 5 of the vehicles, 2 of them were another branded EV, electric vehicle. So just to give an idea, gas in the gas station in San Francisco, presently, up to last week, was about $4.90 US per gallon, plus tax. So when you check that mathematics, you're looking at 9.5% is the tax on purchases, and you're paying $4 plus. So when you think about it, you're paying over $5 US, which is approximately almost $40. So you're paying almost $40 for a gallon of gas to put in your vehicle to drive around the place, when you could have an electric vehicle, and charging at most of the charging stations across there, it's free. So in other words, once you buy your vehicle, you plug it in, and I've seen, because there's so much technology-based companies, I've seen charging stations at restaurants, at hotels, at the airport, at downtown San Francisco. I've seen it in some of the more modern restaurants. So for example, you park up to have something to eat, and you plug in your vehicle while you're paying to park. So you're paying to park for the parking spot, but you have the option of plugging in your vehicle to charge for free. So it comes like you're getting gas for free. So I would understand now why some people will actually gravitate towards going with an EV as opposed to a traditional vehicle. One of the things that I saw as well with regards to technology and technology-based equipment, we would have seen cartoons, for those of you who would have grown up in the times of the Jetsons. We would have heard of flying cars, we would have heard of robots in your home, robots as a nanny, robots in your business, and so on. What I have seen, well, up to last year in Orlando, for example, I saw there was a vacuum, or a robot vacuum, in one of the gas stations. So you stop off at the gas station, you go in, and when you go into those concession areas, you're not going to have a human being doing the cleaning. The human being is the one selling you. but you actually have robots, actual physical robots. It's a robot vacuum. It has a face and everything, speaking English, but that particular unit moving around and cleaning the place, vacuuming and sweeping and mopping and so on. I saw that last year. What I saw this year is something that well, of course, it is available, something that was very intriguing, and that was self-driving cars. And I didn't see one, I didn't see two, I didn't see three. I see several. I mean, I saw a lot of them on the highways. I saw them on the street while I was walking. I saw them parked up. And how it works is that there's a company in San Francisco called Waymo that is run by Google. And these vehicles, of course I'm going to show you a clip on it, but these vehicles actually drive on the road for themselves, and in some cases they might drive safer than human beings because it's fully electronic. The way it navigates, it actually links by satellite, just like as we would have our mobile phones. You know, most people know, okay, we use our phone, we go on Google Maps or we go on Waze or one of those things, and we can see the streets and we can then navigate. It will speak to us while we are driving. These devices are completely seamless in terms of interaction with the technology. So in other words, it links to your traffic cameras. It links to the cameras that's mounted on the post where there's traffic lights. It links with cameras on the typical lampposts. And then there are sensors right around the vehicle, including a 360-degree mobile sonar. So it actually sends out a sonar similar to how you would have a submarine. And then there's also a radar built into the system. So, I mean, it was totally interesting to me because I actually stopped and I looked several times at these vehicles driving on the road. It slowed down, it waited for people to walk across the road. And when it detected that no one was there, it drove off. In some cases, when it was on a street, it stopped, it put on the indicator, and then when the road was clear, it drove. It stopped at the traffic lights, it waited for the light to go from red to green, and then it drove off. It was something totally out of this world. But again, that is the world we're living in. And whatever we see outside, eventually what's going to happen is going to spread its wings and it's going to go on to different parts of the world. And you never know, you might have that in Trinidad sometime in the future. Hopefully they will fix all the potholes, all the bumps, all the humps, and maybe widen the road so that we can accommodate the number of vehicles we have in Trinidad. We take a little break, and when we come back, I will show you some videos on the Waymo. Let's take a break.
Assalamu alaikum. In this, our 20th anniversary of existence, we here at IBN want you to be a part of our family. Call us at 663-4762 or 795-5900. Those numbers again, 795-5900 or 663-4762, and be a part of our advertising campaign. Glorious and available rates to you and your company. So remember, call us here at IBN 663-4762 or 795-5900 and be a part of the IBN family.
Welcome back once again to IBN's Techno. I am your host, Dr. Shahan Shali Kasim, and if you are looking at this program for the first time, as I said, this program is aired live from 8 to 9 p.m. on Thursday evenings right here on IBN. Our topic dealing with technology and topic dealing with processors. As you would have seen right before we went on the break, we spoke a little bit about the Intel processors. We spoke about how it is integrated into the circuit board in a computer. And fortunate enough, there is some newer advance of technology, and we will look at that now. Introducing the 13th generation Intel Core processors for desktop computers. Let's take a look.
Welcome to a world where you are not constrained by time nor space, not forced to play by the rules. Things are different. You have the speed to be anywhere or everywhere, the power to create worlds at a whim. The presence to capture the attention of masses with a single post. You will discover the curious, the enthralling, the strange, the wonderful, and find no boundaries save for those set by your own imagination. Get unrivaled performance for everything you do with the fastest chip we've ever built, the 13th gen Intel Core processors. Welcome to a world that you define. How wonderful is that?
Right, for many of you guys out there who have been looking on this program and who have been following technology over the years, that little clip at the end, that's music to one's ears, especially when it comes to the Intel processor. I was speaking earlier, right before we went on the break, I was talking about self-driving cars. Now think about this. We know about, or we heard about Uber, we heard about Lyft, we heard about rideshare, whereby people have vehicles and you pick up the phone and you use an app and you order a vehicle to come pick you up, and you have a driver who will come to pick you up at a particular time, and you can track that particular vehicle, you can check the vehicle driver and so on. But what if I tell you there's a technology, not tomorrow, but it already existing in certain parts of the United States. San Francisco is one of them, and there's a few other places that it exists, that you can pick up the phone, download an app, and you can order and pay for with a credit card, or even sometimes a tap through NFC, a driverless or self-driving car. So you want to go somewhere, you pick up your phone, you order a pickup, it will tell you where is the closest vehicle, how long it will take to reach, and you can do a tracking in terms of where it is, how far it's going to be to arrive to your location. And then when you board the vehicle and you're going to your destination, you can basically track the arrival time, traffic, and so much other things. But let me don't tell you too much about it. Let me just show you what I'm talking about. Our video that I'm going to show you now, the magic of Waymo, is a technology that is run by Google. And this is self-driving cars. Let's take a look.
So much emerging technology is just a show, so one can be forgiven for not being able to distinguish fact from fiction. Take this car, for example. Can it drive autonomously or not?
The short answer is absolutely.
That was Shweta Shrivastava, Senior Product Lead for Driving Behavior at Waymo.
What you're looking at is the Waymo driver in action. Adapted for a variety of vehicle platforms, it is the most advanced, fully autonomous driving technology in the world today.
What you notice pretty quickly is that these aren't normal vehicles. Take this Jaguar I-Pace, for example. It's been equipped with an elegant array of sensors and software, which allows it to move through the city on its own.
That's correct. The Waymo driver is a combination of custom-designed hardware and software that is responsible for performing the entire act of driving.
That was James Philbin. He's an engineering lead on the perception team at Waymo. I asked him to break down the technology for us a bit more.
The Waymo driver handles the task of driving in 3 basic steps: sense, solve, and go. It's the way we describe the highly complex process of acquiring information, processing it, and moving through the world safely.
So, what goes into all that sensing?
The sensors that the Waymo driver uses are incredibly powerful, using a combination of LiDAR, cameras, and radar. It can see up to 3 football fields in any direction and can detect sirens from emergency vehicles, which allows the Waymo driver to visualize the world around it in milliseconds to a high degree of accuracy.
Okay, sense makes sense. But what do you do with all that data?
Good question. The system calculates the predicted future behavior for each relevant agent in the scene. Then, with a strong foundation derived from artificial intelligence and machine learning algorithms, the Waymo driver crunches all that data and calculates a safe route, while responding in real time to the evolving traffic environment.
If I understand correctly, this means the Waymo driver continues to learn as it goes, is trained and tested on scenarios that it's never seen before, and can differentiate safe and comfortable driving behaviors from hazardous and uncomfortable ones.
Yes, well done.
Why, thank you. The final step in the Sense, Solve, Go methodology is perhaps the most straightforward. Go.
Once the Waymo driver has determined the path to take, our advanced motion control systems allow for smooth acceleration and braking on hilly streets, or managing bumper-to-bumper traffic with safe and natural driving movements.
So it's really here, right now in cities. Not smoke and mirrors, but true autonomous driving technology. Waymo is taking what was once futuristic sci-fi and making it non-fiction. And like all great technology, all that number crunching, all that data just fades into the background. And you realize the dream of riding in a fully autonomous vehicle to your favorite dinner spot isn't just a vision of the future. It's actually happening right now.
And that technology, as I said, is not tomorrow. This technology exists already. I've seen it, I've witnessed it firsthand, and it's a remarkable piece of technology. But I see we're out of time already. So until we see you guys next week, Thursday, right here on IBN, I am your host, Dr. Shahansh Ali Qasim, wishing you a safe, productive week, a beautiful weekend. Until we see you again next week, Assalamu alaikum wa rahmatullahi wa barakatuh. May the peace and blessings of God Almighty be with you and your families.
A meeting of friends, a familiar place, the first sip of something special, a moment of connection, a journey into nature, the sound of flowing water, the warmth of the sun, laughter, friendship, and a taste as bright as the moment. A bond between father and son, lessons passed down, memories created, the cool touch of the river, the crackle of a fresh drink. Moments like these are what stay with us forever. A sip of serenity, refreshing and pure, the gentle rustle of leaves. A push beyond limits, strength in motion, every step, every heartbeat, every challenge met with unstoppable power inside. The fuel to go further, to push harder, to be more. The grind, the focus. And at the end of the day, we come together. A table full of flavors, a room filled with laughter, a night of stories and memories. Different tastes, different moments, but one feeling. Because the best things in life aren't just tasted, they're shared. Taste Sultan drinks now. You know what you drink.
Chic Leisure Limited, making life easier. Our renowned great tasting vermicelli comes pre-cut in regular and parch, packaged to make preparation simple. Attention all doubles vendors and roti makers, try our high quality pre-sifted bromate free all-purpose and whole wheat flour, low price and conveniently packaged. For wholesale and retail prices, contact Chic Leisure Limited, Warrenville, Conopia. Chic Leisure Limited, quality you can trust.